Yes, so notes 20 is complex numbers. Remember I talked about before this great thing called imaginary numbers. And I forgot that we introduced that topic in this course, but we're not going to go into depth. I'm just going to tell you this is what an imaginary number is. And then you'll get to do so much more of that in college algebra next. So an imaginary number is not a real number, right? So if you were to think of a quadratic equation, so like a parabola, we know that where the parabola crosses the x-axis are its real roots. Well, sometimes we have parabolas that when we graph them, they do not cross the x-axis. And so what we do is we think of, okay, imaginary roots, if it crossed this imaginary line. Okay, what would those roots be? The big idea here is that when we see the letter I, we know that it's defining an imaginary number. So giving you the formal definition, imaginary numbers are numbers you get if you take the square root of a negative. So before we would say, okay, the square root of negative 64. Well, we know that is an even nth root. We can't have negative, so it must be no solution. Well, from here on out, since we're introducing imaginary numbers, we are not going to say, okay, if it's no more, no solution. It's going to be a solution, just not a real one.
So, question.
Yes.
On the final exam, for any of the previous questions from previous tests, the ones that were no solution, do we put this now or do we leave it?
That's a good question. I will answer that question a different day.
Right,
I have to make the test first. I'll try not to do that, so there's no confusion, right? But that's a good point. Okay, so it says let b be a positive real number, then the square root of negative b is equal to I square root of b. So what happens is they take this negative out and turn it to I. And so that's all we're going to do for these examples here. So for this first one, before we simplify that square root, we're going to rewrite this as I times the square root of 64. We remove the negative and call it I. From here, if we're able to simplify the square root, that's what we're going to do. So what's the square root of 64? 8. So our answer is 8I. That's it. Okay. Same with this next example.
Is this almost like, what is the other, the two lines?
Oh, the absolute value?
Is it almost like an absolute value? Or
It's absolute value in the aspect that you're getting rid of the negative,
Yeah.
but there's no correlation between imaginary and absolute value.
okay. Because absolute value is like the absolute value of 8 or plus or minus 8, correct? Or how do you
Plus or absolute value of, so when we talked about absolute value, that was us saying if we had like x squared equal to 4, if we were to take the square root, that's the same as saying x is equal to the absolute value of 2. It could be positive or negative 2 because we're squaring the number. So if you square a negative, it's positive. Square a positive, it's positive. But no correlation to imaginary. I don't want you to think they're the same. Okay, so the next one, we already have a negative on the outside, but we still have a negative on the inside. So we're going to rewrite this as what on the outside? Negative I square root of 4. And what's the square root of 4? 2. So this is negative 2I. When will it be plus or minus? Not too many times, not too many times in this course. It won't be plus or minus. Because anytime we did like the example I was showing, like x squared is equal to 4, we were always talking about real world problems, like speed, time, distance. And so we had no need for the negative part. So we always said positive. But if you were given this, let's say in college algebra, and they were to tell you to solve, you would have to say x is equal to either the absolute value of 2 or plus or minus 2. It's going to depend on what they're asking in the next course.
If it was negative, it would be I plus or minus 2. Or plus minus 2.
Oh, I see. If you're solving, yeah, if you're solving. Like if we had a variable in here, solving for the variable, yeah, that'd be a little different. But we're not doing anything that complicated for this course. Okay, next example, we have the square root of negative 50. So first, I need to rewrite this as
50i.
good. So I, and then the square root of 50. But the square root of 50 is not a perfect square root, okay, which means we have to use the prime factor tree to simplify it. So I'd always start with 2, and 2 goes into 50 25 times. And then what number can go into 25? 5 and 5. So I circle my pair. That tells me that my 5s are coming where? Outside. So I have 5i times the square root of 2. That would be my answer. So if we can simplify the radical, we want to simplify it. We might not be able to get rid of it completely. That's why our answer had the square root still in it. What about the next one? How would I write the next one? I times the square root of 29. And then we should try to simplify this. But we know we can't divide by 2 because it's odd, right? Can we divide by 3?
No.
No, so we try 5. Can we divide by 5? Then we try 7. No. And so by the time we get to 7, typically it's not going to work. You could continue going to your prime numbers, 11, 13, your next one, and divide into them. But we'll notice here that this can't be simplified because 29 is prime. And so that means our answer is just going to be I times the square root of 29. That's it. If we can't simplify it, we can't simplify it. There's nothing else we can do. Okay, the next 2 examples is, okay, well, let's say we are dividing or multiplying. Okay, so if we're dividing or multiplying, we still are going to treat these as separate radicals. So we still need to simplify these separately. So if I look at the top, how would I rewrite that radical? Square root of 100.
Oh, we're not.
I'm just writing step by step, but you are right. It would be I times 10 or 10i. How would I rewrite the next one? Square root of 25. And these are both perfect squares. So the square root of 100 is 10. So we have 10i. And then the square root of 25, 5i. And just like we could cancel out our variables, we can cancel out the i's. So since we have I divided by I, these cancel. So the i's are now gone. And can we simplify 10 divided by 5? Yes, what would that be? 2. So our answer is just 2.
So it basically gets rid of the negative.
Yes, it got rid of that negative under the radical when the i's canceled out.
Because technically we can still work with the negative, right? We can still do the math with the square root is negative 100. Oh, no, we can't.
No,
It's an
because if,
even number.
yes, so because of that, if we didn't have imaginary numbers, this would just be no solution. We could not.
The problem in the last exam,
Mm-hmm.
we could have used this, perhaps.
Correct. And I think that was his question. So like when we're on the final exam, what does that mean for the previous problems we did similar to this? And I said, that's a great question. I will let you know later. Either or. I will decide once I write the test. Okay, so same thing with multiplying. We still have to deal with them separately. So we just said that the square root of negative 25 is I. Good, times the square root of 25, which is 5I. And then how would I rewrite the second one? I square root of 9. Okay, so we simplify the radicals now. So I have 5I times 3I. And then I multiply. Good, so I treat these like I do variables. So an I times I is going to be I squared. So this is 15I squared. Okay, I squared is negative 1. Anytime we have an I squared, that is equal to negative 1. So really, this is 15 times negative 1, which is negative 15. That would be my answer. Okay, so an I by itself, we can't do anything. That's just I. I squared, or I to any positive even exponent is always going to be a negative 1. Okay. Any questions so far?
Only I squared?
I squared. So like if we had like I to the 4th, we know I to the 4th would be I squared squared. So it would be negative 1 squared. So it really is going to depend on if we have more than just that I value, and there's actually a chart on your notes that we'll go over. Okay, so for this one, this is I square roots of 5 times I square roots of 5. Okay, square root of 5 times the square root of 5 is the same as saying what? So it could be two ways you guys are saying it. Square root of 5 times square root of 5 could be the square root of 25. We could multiply the insides. Or we could say the square root of 5 times the square root of 5 is the square root of 5 squared. Right? So this could be I squared times the square root of 5 squared. It would be negative 5, yes. Because this right here is negative 1. This radical cancels out with the exponent. So we have negative 1 times 5, which is negative 5.
Would it be considered wrong if it was negative 25? Or does it need to?
So it would be wrong if you did negative 25, only because what you would have done is I squared times the square root of 25, which is still 5. So it'd still be negative 1 times 5, which is negative 5. So either way you did it, if you multiplied inside the radicals to get a number, you still have to simplify. Okay. And then one more of these examples. Okay, so going straight to simplifying the radical, what do we have for the top? 12i over 4i. Good, because this is I times the square root of 144, which is 12, so 12i. And I times the square root of 16, which is 4, so 4i. What happens to the i's? Cancel, and can we simplify 12 over 4?
Yes.
2, 3, that's our answer.
Is there gonna be any check on these?
On a check, I don't believe so. Okay. So then we bring us to the second concept, which is the power of i's. So here I give you a little cheat sheet, right, of if we had I to the 5th, I to the 10th, I to the 12th, what that would be. When you see this, I want you to think, okay, I to the 5th, we're going to use this as an example, is the same as saying I squared times I squared times I, right? Because we would add all those exponents together. 2 plus 2 plus 1 is 5. Okay, these are the exact same. Well, we know that I squared is -1. So this is the same as saying -1 times -1 times I, which is positive I, because a negative times a negative is a positive. So that's where this came from. So anytime you have a higher degree besides I squared, you would have to write it out to determine if your I is going to be a positive I, a negative I, a 1, or a -1. Those would be your only options there. Okay. So you could do the same thing with, let's say, I to the 7th. This is I squared times I squared times I squared times I, right? If we add all the exponents, we get 7. 2 plus 2 plus 2 plus 1. And we know that this is the same as saying -1 times -1 times -1 times I. And so a negative times a negative is a positive, but what's a positive times a negative? Negative. So that's how they got a negative I here. Okay. If you didn't have the cheat sheet, but will you have the cheat sheet? You will, right? It's more of keep this in mind for next class. Okay, the next class after this class. Okay, so let's go ahead and look at these examples. So we have I to the 13th. Okay. How do you know it's -I? We're going to go through the steps. Well, we already have I to the 12th, right? So this is the same as saying I to the 12th times I. That would give us I to the 13th. Well, I to the 12 is 1 times I, which is equal to I. Okay, so that's how you would use that cheat sheet. You would go here and be like, okay, how can I make the new exponent based off the ones I'm already given? So for example, how could I get I to the 18th? This is the same as saying I to the, there's so many different ways you could do this. So let's say we use I to the 12th. What would we have to multiply it by to get 18? I to the 6, because 12 and 6 gives us 18. Well, I to the 12th is 1. What's I to the 6? -1. So our answer is -1. Can we do this for each one? So we'll do 107 last. That's a larger number. How could we get I to the 32? 12, 12, 24, 24, and 8, 32. Yep, we could do I12 times I12 times I8. So we have 1 times 1 times 1. So we have our answer of 1. Okay, and what about I to the 107? I mean, it could be a -I, but what would be your steps leading up to that? So there's so many different ways, right? So let's say you're totally lost. You don't know what to do. This is a large number. This is past 100. We'll start with I to the 10, right? I to the 10, if we were to do this, how many times would give us to 100? 10 times, right? Because it'd be 10 plus 10 plus 10. Okay, so that's the same as saying to the 10th power. Okay, then we only have 7 left, which we could use I to the 7th. Well, I to the 10th is -1. -1 to the 10th power times -I. Okay, Since negative 1 is to a positive power, that means every time we multiply negative 1, it's going to have another negative next to it, which means it's always going to be a negative times a negative is a positive. So this is going to give us positive 1 times negative I, which is negative I. Okay, or you could have added I to the 12th several times until you get close to 107 and then add another I. Okay, there's so many different ways you could do this. Any questions on this example? Okay, so then we're going to talk about the definition of a complex number. So I'm not going to read through all of this. All you need to know is that if we have a real number with an imaginary number, it's a complex number. Okay, real with imaginary is complex. Okay. So in these examples, it says circle the real numbers and box the imaginary numbers. So anytime it has an I, you know it's imaginary. So I'm going to go ahead and first just box all the ones that have an I. So this has an I, this one does not, and this last one has an I. Notice in that very first one, I only boxed the part that's imaginary. Because what would this negative 8 be? It would be a whole number. It's real, so I would circle it. Okay? I'm circling the 3 has because it's only real. They have no imaginary. And then the last one, I boxed the entire thing because that entire thing attached to the I is imaginary. There's no real part. Okay, so really we had real, imaginary, complex, because it had both. Now let's look at how we would add, subtract, and multiply these complex numbers. Okay, so starting off first, we have 1 minus 5i plus negative 3 plus 7i. Notice we are not foiling here because we are adding these two types of imaginary numbers. And what we do is we are going to add only like terms, just like we do with the variables. So we can only add i's with i's. So imaginary with imaginary, real with real. Okay, so I'm just... Negative 2 minus what? Plus 2i. Yes, that's correct. So what we do is we take the real part. So I do 1 and negative 3, and that gives me negative 2. Okay, so I'm adding them together. 1 plus a negative 3 is negative 2. And then I do the same with the imaginary part. Negative 5i plus positive 7i gives me plus 2i. So this is negative 2 plus 2i. This whole thing would be my answer. So I can only add the like terms together. Imaginary with imaginary, real with real. Yes?
Can you divide it? Could you divide it? Could you divide
like
2i by 2?
divide 2i by 2? You could, but it would only, since you're dividing by a real number, it would only mess with the real numbers. You would still have the I there. Okay, and so on this one, we're now subtracting them. So I have negative 1/4 minus 1/2. So negative 1/4 minus 1/2. And then I have 3/4 I minus a negative 1/10 I. What's going to happen with that minus a negative? Plus, so this is 3/4 I plus 1/10 I. Okay, so in order to combine these terms, I'm going to need a what? Common denominator. So looking at the real part, I have negative 1/4 and negative 1/2. What would be the common denominator?
8.
Okay, 8 could be 1. Is there something smaller? 20 could also be 1, but there's something smaller. 4, right? 4 can divide into 4 and 2 can divide into 4. So that means we don't need to change the first fraction. We just need to change the second one by multiplying it top and bottom by 2. So that means we have negative 1/4 minus 2 over 4, which gives us negative 3/4. And then what would be the common denominator for the imaginary part?
Oh, I thought we were doing the one below that.
Oh, well then you got it right, 20. 20 is the one that would work for both, because we would multiply this one by 5 and this one by 2.
Wait, why is it plus? Plus?
Oh, plus, because we had minus a negative.
Oh,
So that turns into plus a positive. Okay, so then we have 15 over 20i plus 2 over 20i, which gives us 17 over 20i. So I have my answer of negative 3/4 plus 17 over 20i. And typically you do put your real number first, then your imaginary number. Okay. Okay, so in order for us to add these, we're going to have to do like we did in the very beginning and convert this into imaginary number. So how would I convert the square root of negative 8? I square root of 8, and then we'll have to do the tree. What about the next one? I square root of 18, and again, I have to do the tree. So for 8, this is 2, 4, and then 2, 2. So we would write this as 2i square roots of 2. And then the next one would be 2, 9, 3, 3. So this would be plus 3i square roots of 2. Okay, we could only add these together because both of the radicals are exactly the same. Okay, so if they were different, like if this last one was the square root of 3, we couldn't add it together. That would just be our answer. But since this is the square root of 2 and this one's the square root of 2, we're just adding together the coefficients, the i's.
5i square root of 2.
Yes, so this is 5i square root of 2. That's our answer.
I like that it's still applicable for future. It's gonna be, are we gonna be able to use that for future references still?
What specifically?
The variables, matching the.
Oh, yes, yes. Yeah, definitely. Remember, this course is just touching base of all the topics you're going to be in college algebra. So when you get to college algebra, you're going to be like, okay, I already saw this. Piece of cake. And then they'll throw out something a little harder. Okay, so this one we're multiplying, which means we have to do what? FOIL. And we're going to treat these i's just like we did the exponents. So if I was to FOIL this, I would first distribute the 10, then distribute the negative 5i. So I have 10 times 2, 20. 10 times 3i, 30i. On the bottom now, negative 5i times 2, negative 10i. And then the last one, negative 5i and 3i, is negative 15i squared, right? Because I have an I times an I, so it's I squared. So I know that I squared is what? Negative 1, right? So technically I have 20 plus 15, because negative 15 and negative 1 is positive 15, and then 30i minus 20i. So that gives me 35 plus 10i, and that's my answer.
Yes.
Yes.
How is this different from the first one we did in concept for?
The first one, oh, because this one is adding.
Where
Mhm.
did the 20i from?
Where did I get 20i?
You said it's plus 30i minus 20i.
Oh, that's my bad. I was trying to bring down the minus 10, but I did the math in my head. So technically it's plus 20i. Thank you. Right? No?
So you subtracted the 30 and
30
the 10,
minus
so it made it 20.
10 is
Yeah, because I did the 20 and the positive 15. I rewrote it. And I just brought this down. And then so 20 and 15 is 35. 30 minus 10 is 20. Right? Okay. Okay.
I have almost 7
Sorry?
We only have 7 minutes left in this class.
Well, if you're devoted, right, you have more time. Right? I did not know it was going to take that long to get through everybody. It's okay. If you have to leave in 7 minutes, you have to leave, right? I'll be talking to myself then. Because I'm not going to stop this video and re-record. Okay.
We have 3 more questions.
Yeah, I'm recording right now. Yeah. I would just be talking to myself and be like, right? That's how I am when I'm recording my high school videos, because I record them at home, not with them, because they're crazy. They'll be like trying to be crazy in the video. So I'm like recording. I'm like, okay, and then we do this. And I'm like, oh, wait, I'm by myself. Yes, of course we do this. Okay, so we have 1.2 times 1.2.
1.44.
1.44, thank you, 1.44. 1.2 times negative 0.5i. Negative 0.6, right? No. 0.6? Okay. Trusting you guys, okay. Next one, 0.5i times 1.2, so that'd be a positive 0.6i. And then 0.5i times negative 0.5i would be negative,
Negative 0.25.
good, times I squared. So notice my middle terms are gone. What happens with the I squared? Turns to negative 1. So I have 1.44 plus 0.25, because minus a negative is plus a positive. And so this gives me 1.69. Okay. Technically, if I wanted to write this as a complex number, I could say this is 1.69 plus 0i. Right? Because what's 0 times anything? 0. This is what it would be complex. In case Alex is like, well, I don't like 1.69, show me complex, right? Well, you just do plus 0i.
Alex is picky.
Very picky. Okay, we're almost done. Any questions? Okay, last topic. And there's only 2 questions. See, I can do it in 4 minutes. Okay. Division and simplification of complex numbers. So here, it's almost going to be like our radicals, where we had to rationalize the denominator. Okay, so just like the radicals where we didn't like a radical in the denominator, they don't really like i's in the denominator. So in order to get rid of them, we're going to multiply by the conjugate. So in this example here, what would be the conjugate? 5 minus 2i. Okay, And then that means I need to multiply across. So I need to FOIL the top and then FOIL the bottom. Okay, so I would get, so exactly this. Looking at the numerator, I would have 20, so that's 4 times 5. And then 4 times negative 2i would be negative 8i. Negative 3i times 5 is negative 15i. And negative 3i times negative 2i is positive 6i squared. And I would do the same thing on the denominator, FOIL again. But this time when I FOIL, what I'm going to notice is my middle terms are going to cancel. So really all I have to do is 5 squared minus 2i squared. Exactly how I did with the radicals. Very important that this is always minus, no matter what. No matter if our conjugate is positive, always minus. Because when we FOIL it, we're doing a positive times a negative, which gives us a negative. Okay, so simplifying this, I know that this is going to turn to negative 1. So really, I have 20 minus 6, so that's 14. And then negative 8i and negative 15i gives me negative 8 and 15. 23i.
That is 23.
23i. Yeah, because it's both negative, so we're adding them. And then we have 5 squared, which is 25. And then this minus 2i squared, this 2 is being squared, and the I is being squared.
So that means that it's going to be a positive.
So this is a negative 4i squared, which is negative 4 times negative 1, which is positive 4. So this is plus 4. So I have 14 minus 23i over 29. Okay, and that would be my answer. And then this last example, notice that there's not an I in the denominator, which means I don't need to multiply by a conjugate. Instead, it wants me to see if I can simplify any further. Okay. Okay, so this one right here.
Yes, would be 2 times 9 and 2, so that means.
Oh, you mean the radical? Yes, so that's exactly what we would do. So since there's not an I on the denominator, I'm going to take the square root of 18, and I'm going to do the prime factor tree. So that's 2 goes into 18 9 times, 3 goes into 9 3 times, so I have a pair of 3's. That 3 is going to come out. So I have 6 plus 3i square roots of 2 over 9. And now that I simplified that, notice how I have a 6, a 3, and a 9 all on the outside, which means I can simplify by doing what?
Divided by 3.
Dividing by 3. So this is just 2 plus I square roots of 2 over 3, and that would be my answer.